Section 10.3, using permutations and combinations. A permutation is another word for an arrangement of objects. Example 1, Club N is Alan, Bill, Kathy, David, and Evelyn. How many ways can club members arrange themselves in a row for a photo? There are 5 people in the club, so 5 people could be in the first position, 4 people could be in the second position, 3 people in the third position, 2 people in the fourth position, and 1 person in the last position. Multiplying those numbers, 5 times 4 times 3 times 2 times 1. There are 120 ways the club members can arrange themselves in a row for a photo. How many ways can Club N select a president, secretary, and treasurer if no one can hold more than one office? We are counting permutations of 5 things taken 3 at a time. There are 5 members of the club, and we're choosing 3 of them for president, secretary, and treasurer. Order matters. You can't be the president and the treasurer. 5 people could be the president, but then 1 person is selected for the presidency. 4 people could be the secretary, then 1 person is selected for the secretary, times 3 people that could be chosen for the treasurer. There are 60 ways the Club N can select a president, secretary, and treasurer. The permutation formula. The number of permutations of n things taken r at a time is NPR equals n factorial divided by n minus r factorial. It's a permutation, so the order of the items matters. Example 2. 10 items taken 6 at a time. 10 factorial divided by 10 minus 6 factorial. Writing out those multiplications. And then 4 divided by 4 is 1. 3 divided by 3 is 1. 2 divided by 2 is 1. And 1 divided by 1 is 1. We're left with 10 times 9 times 8 times 7 times 6 times 5. 10 things taken 6 at a time. There are 151,200 ways. Example 3. How many non-repeating 3-digit numbers can be made using the digits 3, 4, 5, 6, 7, 8? 6 things taken 3 at a time. Order matters, it's a permutation. 6 factorial divided by 6 minus 3 factorial. Writing out the multiplication, again, 3 divided by 3, 2 divided by 2, 1 divided by 1. We're left with 6 times 5 times 4. There are 120 non-repeating 3-digit numbers made from the digits 3, 4, 5, 6, 7, and 8. Example 4. Account numbers consist of 2 letters followed by 4 digits followed by 3 more letters. Repetitions of numbers and letters are not allowed within any of the 3 groups, but the last group of letters may contain one or both of the letters in the first group. How many account numbers are possible? Think about how many letters are in the alphabet, how many digits we have from 0 to 9. So it's going to be 26 things taken 2 at a time, 10 digits taken 4 at a time, and 26 letters taken 3 at a time. Writing out the multiplications. and the factorials. Simplifying, we have 26 times 25 times 10 times 9 times 8 times 7 times 26 times 25 times 24. Multiplies to 51,105,600,000. That's how many different account numbers we get with 2 letters, 4 digits, and 3 letters. With permutations, order matters. When we're talking about combinations, order does not matter. It's read as n choose r. N factorial divided by r factorial times n minus r factorial. It's a combination. The order of the items does not matter. Example 5, we're talking about Club N again with Alan, Bill, Kathy, David, and Evelyn. How many ways can Club N select a 3-member committee? Again, repetitions are not allowed, but order selected no longer matters. We're talking committees now, not president, secretary, and treasurer. So we have 5 people and we're choosing 3. 5 factorial divided by 3 factorial times 5 minus 3 factorial. Writing out those factorials. 3 divided by 3, 2 divided by 2, 1 divided by 1, are all 1. 5 times 4 divided by 2 times 1. There are 10 possible 3-member committees. Example 6 is 14, choose 6. 14 items, and we're choosing 6 of them. 14 factorial divided by 6 factorial times 14 minus 6 factorial. 14 factorial divided by 6 factorial times 8 factorial. Writing out the multiplications. Simplifying. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 appears in the numerator and the denominator. 14 items, choosing 6 of them, there are 3,003 possible combinations. Example 7. How many 5-card poker hands can be dealt from a standard deck of 52 cards? There are 52 cards and we are choosing 5 of them. So it's 52 factorial divided by 5 factorial times 52 minus 5 factorial. Simplifying. Writing out the multiplication. There are 2,598,960 5-card poker hands from a standard deck of 52 cards. Example 8. Carrie wishes to buy 10 different paintings, but can only afford 4. How many different ways can she make her selection? There are 10 paintings and she is choosing 4. It can happen in any order, so it's a combination. 10 choose 4. 10 factorial divided by 4 factorial times 10 minus 4 factorial. 10 factorial divided by 4 factorial times 6 factorial. 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. She can select her 4 paintings from the 10 different paintings in 210 ways. In a multi-part task that satisfies the uniformity criterion, if repetitions are allowed, use the fundamental counting principle. If repetitions aren't allowed and order matters, it's a permutation. If repetitions aren't allowed and order doesn't matter, It's a combination. It's part 1 of section 10.3, using permutations and combinations.